Hey everyone, so today we're going to be discussing how substitutions can help you solve complex integrals. This method is known as U-substitution, where we can sub out a complex function in the integral for the variable u. By doing this, we end up getting an easier integral that we can solve in a much quicker amount of time, and it just makes it a lot simpler. However, before we get to solving problems and really learning how to do U substitutions, I have to explain when something can and should be substituted for U. For the majority of the time, U substitution is used when dealing with complex integrals. However, even though a problem may look really daunting at first, as long as you make the correct substitution, it turns into a very simple kind of integral. Due to this, a really good rule of thumb for U substitutions is that whenever there is a complex problem where you should use U, especially when it involves a nonlinear function, you should go and make that substitution and then from there solve the integral, and it becomes a much easier process. As for the guidelines on what you should substitute U with, typically it's more of a guess and check kind of process, and the more you do it, the more you practice it, the better you get. However, the main rule of U substitution is you want to substitute out whatever function could cause a cancellation within the integral. In the problem I will be doing, you'll see what I mean by this. For our first example problem, we have integral of 6x times root 3x squared plus 1 dx. Now, what we want to do is we want to be able to cancel out this 6x out here with whatever we substitute u in, because otherwise if we have two different variables within the integral, it does not work. So what we want to do is we want to set u equivalent to whatever could cancel this out. So by the looks of it, it would be 3x squared plus 1. Typically with these u substitutions, not only do you want to have it where the u substitution ends up canceling out, for example, 6x, but you also want to have it where it's fairly simple. Anyways, now we have u equals 3x squared plus 1, but we have to be able to change dx into du. So what we do here is we have it where it's du over dx equals the derivative of the u function. So in this case, it will be 6x. So we end up manipulating this around to where it becomes du equals dx 6x, and then dx equals du over 6x. So when we plug that in, it becomes root 6x over 6x times root u du. These ends up canceling each other out, so it turns into the integral of root u du, and this becomes extremely easy, and we end up getting that the integral of u to the half is u to the 3.5, and it's times 2 over 3, and then that's plus c. And then I don't know why I put that there. Anyways, and we just plug in the u back in, so we have 3x squared plus 1 to the 3.5 power all over 3, and then plus c. And that's our first problem. So for our second problem, what we have is the integral of cosine ln x all over x times dx. So first we have to go and pick out what our u value should be. So first let's go look at cosine of ln x. So looking at that, it's a very complex kind of function. So if we use that as our u substitution value, it would only make it more difficult to solve the integral. So by choosing this value right here, it would be counterproductive to what u substitution is supposed to do: simplify the integral and make it easier for you to solve. So this does not work. Let's go look at 1 over x now. Now I'm not sure if you see it by now, but that's fine. From what I know, this 1 over x, what will happen is it won't cancel out this cosine ln of x, because I've explained you can only have one variable within the integral. In this case, it's going to be u. So since this 1 over x will not cancel out this value here and therefore have it where it's only one variable within the integral, 1 over x does not work out. Thus, we have to go and use ln x. So with this, what we do is we do du over dx equals the derivative of ln x, that's 1 over x, and if we cross multiply it, we can get that dx du equals dx. Now we can go plug in these different values and such we have found, and by doing this we can get that it is the integral of cosine u times x all over x and du. What we end up getting here now is these end up canceling out, leaving us with cosine u du. What we do now is we see that we have that sine u, when you find the derivative of it, it turns into cosine u. So seeing that the derivative of sine u is cosine u, that means our final integral will be will be sine u plus c, and then we plug in ln x for u, so our final integral is sine ln of x plus c, and there we go. So for our final problem, we have to find the area of e to the 1 over x squared power all over x cubed. We have to find the area of that between -4 and 4. So there's two ways to do this problem, alright, and first we'll do the long way, alright. So for the long way, we end up solving it as any normal u substitution problem. So we'll say u equals 1 over x squared, and we end up having du over dx equals the derivative of 1 over x squared. So in this case, it's -2 over x cubed, and we end up manipulating it to where we get that our dx value is equivalent to negative x cubed times du all over 2. So when we write that out over here, we end up having -12 integral from -4 to 4 of e to the u times x cubed over x cubed du. These cancel out, and the final integral is -12 times the integral of -4 to 4 of e to the u du, or e to the u du. From here, what we can end up doing is we end up finding the area. So we take the integral of this, which turns out to be e to the 1 over x squared power, take it from this interval, and we end up getting that it's -12 times e to the 1/16th power minus e to the 1/16th power, and these end up becoming 0, so it's just 0. And now you might be thinking, wow, I did all that just to get 0. Well, the reason why is because there's an easier way. So there's two things we have to identify to do it the easier way. And one, we see that the interval is from -4 to 4. So as we know, that's just basically 4. Okay, they're both different values of 4. All right. And the second thing is that when we plug in -x into the equation, all it becomes is negative e to the 1 over x squared power all over x cubed. And as we can tell, it's basically the same exact function, just negative. So with these two things in mind, what we can say is that since the function is odd and that its interval is -4 to 4, the area is 0. And that's it.